So the oblique asymptote, it works similarly to the horizontal asymptote. So it is indicating end behavior. And basically, instead of each side of the graph going towards one specific number, it actually goes to a linear equation. So it says sort of how it decreases or increases on the left or the right. So the first thing is we just have to look at the degrees of the numerator and the denominator. So if the degree of the numerator is exactly one more than the degree of the denominator, there will be an oblique asymptote. So for example, if the degree of the numerator is 5 and the degree of the denominator is 4, then there would be an oblique asymptote. And the example that we have here, there would also be an oblique asymptote, and we're actually going to go ahead and find it. So in this case here, the degree of the numerator is 2. The degree of the denominator is 1. So by the rules of horizontal asymptote, we know that there's not a horizontal asymptote, but since the degree is exactly 1 larger than the degree of the denominator, there's an oblique asymptote. And we find it by using division. So we can use either long division, polynomial long division, or for this particular example, we can actually use synthetic division. So I'm going to go ahead and use synthetic division. And remember that with synthetic division, we can use synthetic division as long as the denominator is in this form. So x plus or minus some number. But it can't get any more complicated than that, or we have to use polynomial long division. So if I'm going to go ahead and use synthetic division, the 3 is going to go in the front, and then the coefficients of the numerator are going to go underneath the long division sign. So the 2 comes first because of the x squared term, and you always have to go in order here. So the x term is missing, so the coefficient is then 0, and then we go back to the constant, which is 5. So long division here, I'm going to bring the 2 down, and then we do 2 times the number out front, which is 3, so that gives us a 6. So I add vertically, so 0 plus 6 is 6, and then we take 6 times 3, which gives us 18, and then we have to add vertically here, so 5 plus 18 gives us 23. So in terms of the remainder, we actually don't use the remainder at all. What we're actually going to use are the numbers 2 and 6. So in terms of when we did division before, what this basically means is that 2x squared plus 5 divided by x minus 3 does not divide evenly because the remainder is not 3. But we'd actually say the result is 2x plus 6 plus 23 over x minus 3. So I'm just going to write that out. So that's actually our result. 2x plus 6 plus 23 over our original denominator, which is x minus 3. So the oblique asymptote occurs right here at 2x plus 6. So our oblique asymptote, I'm just going to write OA for oblique asymptote, occurs at y is equal to 2x plus 6. So when I'm graphing my function, if I were to graph this whole thing, I would actually graph the line y is equal to 2x plus 6 as a dotted line, and then that's what the endpoints of my graph is going to go towards.